scared. It's not a scary squiggle. Okay, parametric equations. What's the point of parametric equations?
Or something like that?
I think parametric equations means an equation in terms of a parameter.
That's another way of looking at it.
Okay. What parametric equations will eventually do for us is describe motion in both directions at the same time. When you did motion last year, we did linear motion, so either right to left or up and down. Once we get some parametric equation calculus under our belts, we can describe motion in both directions simultaneously. Okay, so we need to remember what parametric equations are. Okay, so we're going to have x and y in terms of a third variable. More times than not, it will be t. Every once in a while, you will see theta as your parameter. Were you guys not writing this down? That was the whole point of when I was that was why it was up here. Yes, and then I turned this on and I said, write down what you need to while I'm gone.
We already had it written down. Now we're just writing down what you're saying.
So you're going to have x in terms of t, y in terms of t. You are so full of baloney.
I know.
Okay?
Yes, I don't think half these words are on here. Pretty sure it's like just the header.
That's what I got down.
Pretty sure you're full of it.
I'm actually, I did have to type.
This is what was on my board.
Oh,
It's pretty wild.
okay. You're right. Come on. We were scared.
Okay, two different ways to graph parametric. Okay? We can create a table of values, not just an XY table, but an XYT table of values. Okay? So go ahead and write x equals t squared minus 1 and y equals 2t. Okay? This is telling us that t goes from -1 to 4.
Would the following students please report to the competition gym for your yearbook photo? Skills USA, Leadership Academy, Junior Class Officers, and Senior Class Officers. Again, those groups are Skills USA, Leadership Academy, Junior Class Officers, and Senior Class Officers. Thank you.
Okay, so when we plug in -1, what do we get for x? 0 and for y?
-2.
When we plug in 0, we get -1, 0. When we plug in 1, we get 0, 2. And when we plug in 2, when we plug in 3, what? And when we plug in 4, okay, remember that parametric equations have direction. So you do need to indicate the orientation using arrows on your graph. Since we started here with t equals -1 and ended here with t equals 4, our arrows are traveling in that direction. Since we stop at t equals -4, our graph stops. Okay, it doesn't keep going. What is the second way that we can graph parametric equations? We can eliminate the parameter, convert it to a single equation. go ahead and write these down. Now, would I necessarily need to tell you that t is greater than or equal to 0? No. You should assume that because we have x equals the square root of t. Okay? Now, when we eliminate the parameter, you solve for t in one and plug it into the other. Okay? So essentially, we have, what would be the easiest substitution?
X equals to the square root of 1.
X equals the square root of y. Some of you may even write y equals x squared. However, since t is greater than or equal to 0, what is that going to mean about x? X is greater than or equal to 0. So we only have half of a parabola. Because the domain of t was t is greater than or equal to 0. That is going to affect our graph. Going to affect the domain of our rectangular equation. Get out your calculators. Let me remind you how to graph parametrically in your calculators. Okay, go ahead and change your mode to parametric instead of function. And that way when you go to y equals, you get the x equals and y equals. Okay. So x equals square root of, when you hit that variable button, it's going to give you a t instead of an x. And then y equals t. Then when you graph it, how it's traced out, that's the orientation. Okay? Now, Sean, are you wondering why my parabola stopped?
Nope. Yep.
Yes.
Absolutely.
Well, I don't know how it works on your calculator, but my calculator has very specific parameters, like it goes from 0 to 6.
Right. So if you go to window, you'll see that t is going from 0 to 2 pi. You see that? Like 6.28 is 2 pi. So if you graphed it and it didn't give you all of the graph, you can go to window and you can change your t max. These are the values it's plugging in for t. Let's say we put in t is 10, and then it'll graph more of it. Okay, 0 to 2 pi is the standard. I don't know why. Well, I mean, if we have like sine or cosine, that's why they have 0. But anyway, so you can play around with that. I will expect you to be able to eliminate a parameter and draw a graph without using your calculator. Okay, so just know that that is an expectation that I will have. So let's try this one. I like this one. How in the world will we eliminate a parameter?
Is the -1 inside the cosine?
No, it's after.
Okay.
Ideas?
Not horribly exact.
Perhaps we could do a table, but instead of going by increments of 1, we could go by like increments of pi over 6 or pi over 4 or whatever works. That's an idea.
Okay.
Because I don't really feel like we can apply side.
I don't either. I like your table idea. But there is a way to eliminate the parameter. Do you agree with my algebra right there? Yeah? Do you see where this is going?
Can you? Is that legal?
Okay. Do you agree with this algebra? Do you remember this this identity?
Yes, we can.
So if cosine squared plus sine squared is 1, then wouldn't that mean x plus 1 over 4 squared plus y minus 2 over 5 squared equals 1? Yeah, we don't think that. What do we have?
Something that'll work.
What kind of equation is it?
Circle.
Not quite a circle.
Oh, no, it's a
It's not a square.
Can we
Did
rotate
you
this
say that?
Seas.
Can
Who
we
said
rotate the
square?
conic now?
Oh, you want to rotate the conic?
Yes, please.
No, you do not.
Yeah, you're right.
That was a fun chapter. Okay, we have an ellipse.
With the following students, please report to the competition gym for your yearbook photo. DECA, National Honor Society, both current and new members, Student Council, and FCA. Again, that's DECA,
That means I'm gonna have to go get it.
National
So,
Honor Society, current and new members. Student
let's
Council,
finish this and I have
college
something else for you to
representatives.
write down while I'm gone. Okay?
I'm gonna be gone too.
That's true. Yeah, go ahead.
Okay.
I'll get there. Okay, so, since the 16 is under the X in the horizontal direction, go 4. And then in the vertical direction, 1, 2, 3, 4, 5. Okay. How do we figure out what the orientation is?
And the X-way would have a radius of 4, while the Y-way would have a radius of 5. Okay. Yeah, I missed, back in my pre-calculus, I missed a lot of them, I missed a lot of conics. Like, a massive chunk of it, so.
What are those lines right before the edges?
Oh, the points, those are the foci. Don't
Yeah.
do this. Don't you worry. Okay, so now we need to know what direction to go. So let's imagine, let's go back up to our parametric version. If we plug in 0, what would be our x coordinate?
3?
Okay, and if we plug in 0, what's our y coordinate? 2. So this is when t equals 0. How about when t equals pi over 2? What is our x coordinate?
-1.
Okay, and our y coordinate?
7.
Good. So here is when t equals pi over 2, so we know that our orientation would have to be like so. Oh, not the foci.
No, the ray.
You need to indicate orientation. Yes. Yes, yes, you do. I'm going to try to get through our last example before going down to take a picture. Okay. Here is the definition of a smooth curve. Okay. If we have x and y, we consider it smooth if f prime and g prime are continuous on the interval and not simultaneously zero. If f and g, their derivatives, are both zero at the same time, it is not a smooth curve. Okay, a curve is smooth if f prime and g prime are not simultaneously zero.
At the same t.
Correct. Okay, so how about this? Can you like skip a couple lines and I'll come back for you to write this down? We'll get the example done and then you can come back and write it down. Will that work?
Mm-hmm.
Okay, so I'll come back. Here is our cycloid. It's not a full name.
It sounds like an alien invasion robot sort of thing. Invasion of the cycloids.
Okay, so is this curve smooth? Let's find out. What is the derivative of our x? What's the derivative of 2 theta?
2 times 1 minus cosine.
How about, okay, so can I write it like 2 times the quantity 1 minus cosine? Okay, and what about y prime? 2 times the quantity sine theta. Okay, so we need to figure out, are these simultaneously 0? Right? So when is x prime equal to 0? Okay, if we divide by 2, we have 1 minus cosine of theta. So essentially we want to know, when is cosine equal to 1? 0? Then 2 pi, 4 pi, etc. Right?
You just want to set them equal to one another, and then prove that it's not.
Well, this is simpler to look at them separate and see where they have overlap. Okay, if you set those equal to each other, you have kind of a, it might not be as pretty of algebra. Okay, so now we can look at where y prime is equal to 0. And if we set them equal, we're looking at where they're equal, not where they're equal to 0. Does that make sense?
Wait, so, oh, so just on 0.
Right.
So it's just 0.
It's just the 0. So when is sine equal to 0?
0, 3 pi.
How about 0 pi, 2 pi, 3 pi, etc. Right? So since these are both 0 at 0, 2 pi, 4 pi, yada, 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 then this curve is not smooth anytime theta is a multiple of 2 pi.
Maybe like 2 pi something.
I wrote 2 pi n.
Right.
here is that curve. Notice how there's those corners at every 2 pi? That's because it is not smooth. All right, so I will come back to this slide for you to write down whatever you need to, and I will give you your next gold sheet so you can get started on your homework assignment while I go take this.
Does that mean you can get rid of the old one?
Huh?
Does that mean you can get rid of the old one?
Yep.